For the assessment number of chapter 16, I have chosen a problem mainly related to the system of charged objects. The question goes as: consider a system containing of two uniformly charged plates, capacitor, and a single proton as shown in figure. Suppose that the proton initially is traveling to right and enters the capacitor through a small hole in the left plate. Here you can see the two capacitor and the proton entering to the right side the capacitor through a small hole. While the proton is inside the capacitor, an electric force, an internal force due to the electric field inside the capacitor acts on it, doing work on proton. And the energy principle applied to the system is delta K proton plus delta U electric equals 0. So the first question is, will the kinetic energy decrease or increase? As because the force on the proton acts in the same direction as the displacement of proton, the kinetic energy of the proton increases. When it reaches to a location, let's suppose B, near the negative plate, the kinetic energy of proton capacitor system will have increased by an amount equal to the work done on the proton by electric field inside the capacitor, which is due to all the charged particles on the plates of the capacitor. And due to this, the speed of the proton will increase. Hence, we can also say that in this way the kinetic energy increases. And the number 2 says, will the electric potential energy increase or decrease? As from the problem I, we know that since the kinetic energy increases, the electric potential energy must decrease. And the next problem says, what is the change in electric potential energy of the system? We know that the change in electric potential energy of the system equals to the negative of the internal work. In this case, the work done on the proton by the uniform electric field inside the capacitor. So we can calculate the change in U, which equals negative work internal, which can be separated into component in terms of x, y, and z, which can further be simplified as E delta x. In this problem, E equals Ex, and the y components are 0, both in terms of length, and so the U electric can be simplified to negative Ex delta x, since the other components are 0. So the previous assumption that we made about electric potential energy of the system, that is, it will decrease. You can see, since delta x, which is x final minus x initial, which comes to be positive, and delta Ex equals positive, so the net electric potential energy must be negative. So as said earlier, the electric potential energy is decreased. So another question I just tagged along with this problem is, what happens when electron is used instead of proton? That is, the electron is initially traveling to the right and enters the capacitor through the left plate, and the electron moves to a location B from A to B. So as I said earlier, what happens to the kinetic energy? Since the electric force acts in opposite direction to the motion of electron, kinetic energy will decrease as it moves to location B. And with the electric potential energy increase or decrease? As in previous problem, we see that since the kinetic energy increase, the electric potential decrease. Here you can see, since the kinetic energy decrease, the electric potential energy of the system will increase. And the last question is, what is the change in electric potential energy of the system? As previous, like delta electric equals negative Fx delta x, and the other components are considered to be 0, and putting the respective values, it comes to be Ex and delta x. And just making sure about our previous assumption, delta x equals xf minus xi, initial minus final distance travel, which comes out to be positive, which is positive, and delta Ex equals positive. So this verifies our assumption that the change in the electric potential energy of the system increases is positive. Thanks.